Hi everybody, welcome to this new Juno tutorial. Today we are going to explore some CosmWasm example smart contract, and we are going to deploy one on the Juno testnet. So first thing, we need to find an example smart contract that we want to use. We can start by having a look at the Juno documentation. For example, in the compile a contract section, you can find some useful links and some example smart contract that you can use to follow along this tutorial. Or by going on GitHub in the CosmWasm organization, if you search for CW-, you immediately find a lot of useful repositories full of smart contracts that you can take inspiration from. For example, you have the CW Plus repository, which includes some production-ready smart contracts. For example, the ICS-20 smart contracts, and this contract allows a CW20 token to be transferred through IBC to another chain. So it's especially interesting if you want to start by learning about IBC and how to use it on CosmWasm. Or we have the CW NFTs with all the NFTs smart contracts, or again CW tokens with all the CW20 tokens smart contract. One of the most interesting, for example, is the Merkle airdrop, which allows you to create airdrops for your CW20 token. And finally, I would recommend also to check out the CW Starter template from Kintsugi Tech, which is a very clean and a simple smart contract template that you can use to start a new project. But for this tutorial, I'm going to use CW Clock example from Reese. Reese is one of the lead developers of Juno. And this smart contract is very simple because it has a counter inside, and using a simple message, we can increment it. So it's one of the simplest contracts that I could find, and I think it's perfect for this example. So now that we have an example smart contract to deploy, we need to connect to the Juno testnet and get some Juno X tokens that we can use to pay for the gas fees. To get some Juno X test tokens, we need to go on Discord and find the faucet section. In the faucet section, you will find this API endpoint by Reese that you can use to claim 10 Juno X tokens every 6 hours. But first, let's create a wallet where we will receive these tokens. To do so, we can use the Juno command line and create a new key. And I'm going to create this key called dimitest. This is my mnemonic key. Of course, you should never share this, and you should save it in a safe place. But because this is a test, I don't care. Now that I have an address, I can visit the API endpoint from Reese and paste my address here. Okay, it's loading. Give it a few seconds. Okay, as you can see, the transaction has been broadcasted, and now I should have 10 testnet tokens in my account. To query and check if the tokens are arrived for real, we need to find an RPC endpoint for the unit testnet. Also for this, I recommend going on Discord and using the search option to find for it. And I'm going to search RPC Uni. Uni is the name of the latest testnet. And as you can see, again, Reese is providing us a useful RPC endpoint for this scope. Let's go back to the command line and query the account. We need to specify the address that we want to query. And as you can see, it says balance 10 Juno X. And of course, this amount is in micro denom, so it's multiplied by 1 million. Okay, now that we have everything in place, we can also use the Juno config option so that we don't have to always specify for the node. To do so, let's use Juno D config node, and let's specify the testnet node. Okay, by doing Juno D config, we can check the other configurations that we have. And I already see that the chain ID is wrong, and we need to use the chain ID for the Uni6 testnet. To find it, only Juno D status, okay? And in this JSON, if we look closely, we should find the chain ID. Here, network Uni6. Okay, let's specify it also in the config. No, unquote. Okay, let's verify that the config is correct. Okay, now in the config, I have the chain ID that it's Uni6. I have the node that is the RPC endpoint provided by RIS. I have the gas prices set to 0.001 micro Juno X, and it should be fine. So we are good to go. So now that our command line is configured correctly, we can proceed to deploy and test this smart contract. So let's go back to the CW clock example repository. And inside the repository, you can see that there is a folder named artifacts. Inside this folder, we can find the clock example.wasm file, which is a binary of the compiled contract that we want to test. So we need to go inside here and press the download button. Once it's downloaded, we need to go back on command line and cd into the directory where the binary has been downloaded. In this case, I'm inside my desktop. Now that we can see the clock example.wasm file, we need to store it on chain. And to do so, we need to use the Juno D command line again, transaction command on the WASM module, and the store message. In the store message, if we use --l, we can see which parameters we need to specify. In this case, we need to specify the WASM file, so the clock example, and some flags. In the flags, we need to choose, for example, which key we want to use to perform this store. And so from which key we will pay for the gas fees. So in this case, let's do clock example from dimi, I don't remember which name I use. Let's do the key list. Okay, dimi test, I guess. Okay. Let's use the store again, clock example from dimi test. Let's increase the maximum gas to 1 million. Maybe it's not enough, but let's check. 1 million. Okay, it will ask us to confirm the signing and broadcasting of the transaction. We can specify yes. And okay, not sufficient fees. That's because in gas price we specified in the configuration is only 0.01 Juno X. And the message is quite self-explanatory. And it says we put 1,000 micro Juno as a fee. Instead, he wants 2,500 Juno X as a fee. And so we need to update the Juno D config gas prices to be 2.5 times bigger. So 0.0025 micro Juno. Okay, now that the gas price is set correct, we can repeat the transaction. Let's sign and see. Okay, the transaction is successful. Let's query to see that it actually went through. Okay, this is the log of the transaction. And okay, we can see an error. It says gas wanted 1 million, gas used 1,100,000 something out of gas. This means that 1 million gas is not enough. So we need to increase it even more. So we can try again. Instead of using 1 million, I will use 10 million now, and hopefully it will be enough. Now let's repeat the query of the transaction. Okay, now if we go back, okay, we can see on the raw log field that the transaction is successful, and the code ID that we need to mark down is this one, 3785. What it means? It means that now our code has been deployed on chain, but it's there and it's only ready to be used. Now, if we want to actually use it as a smart contract, we need to say, take these 3785 code ID and instantiate a new instance of a smart contract. And so that's what we are going to do now. So let's mark down 3785 and let's do a new transaction. The new transaction is always Juno D transaction, WASM, and this time we want to use the instantiate message. So to do so, let's use it. Okay, going to copy and paste. And then again, --help, we can see all the parameters we need to specify. So in this case, we need to specify the code ID, which is 3785. And this is JSON encoded init arguments. And in this case, it should be an empty object. But if we want to make sure, we can go on the source code of this smart contract on message, instantiate message, and you can see this is an empty object. On other smart contract, this can be different. For example, if we go to the CW20 Merkle airdrop and we go on the message section, the instantiate message, you can see that you need to specify a node, a CW20 token address, and a native token. So in that case, instead of using an empty object here, you should use an object containing all these parameters. But because we are using the CW clock example, which is very simple, we don't need to specify anything in the instantiate section. So empty object, and then we need to specify a label, and the label can be clock example tutorial. And then we need to specify an admin, and we can use any address that we want. For example, we can use our address, which is this, and amount, this is optional, and we don't need to specify it. Again, we need to specify the key from which we are sending this transaction, which is DMI test. And this time, the default gas should be just enough. The default gas is 200,000, and it should be enough to instantiate a new contract. Only the storing is gas expensive. The instantiate should be quite light because this smart contract is very simple and is not doing anything in the instantiation. So it should be, we should be good. Again, it asks us to confirm all the transaction details, and I'm going to say yes. And the transaction is being broadcasted. Let's query. Okay, this is again the raw log, and we can see that the contract has been instantiated correctly, and we can see the contract address, which is this. Again, we need to mark it somewhere. And now we need to interact with the smart contract. If we go to the source code, we can see that we have one query that is get config. Get config basically is going to tell us the value of the counter. In this case, let's try it and see what it happens. To do so, we need to do Juno D. Now, instead of using the transaction subcommand, we are using the query subcommand, but again on the WASM module. And we need to choose one way for querying the smart contract. So in this case, we want to query the smart contract state on state, and we want to do it in a smart way. The smart way allows us to query only specific messages. So on the smart, and let's again use help to see which arguments we need to specify. In this case is the smart contract address and the query in the JSON format. So again, let's specify the contract address, and the query needs to be specified in JSON format. So in this case is get config and should be an empty object in the parameters. Let's see if it works. Yes, it works. As you can see, we get data value to be 0, which is perfect. Now we can also try the increment transaction so that this counter will increment by 1. And we can see this logic inside the source code. If you see the increment function that is triggered by the increment message, it just takes the config and the value of the counter to be +1, and then it's going to save on the storage. So let's try now to do a transaction to increment the value of the smart contract. Now we can use Juno D, transaction, WASM, execute, and we can use help to see what parameters we need to specify. And again, we need to specify the smart contract address, the JSON encoded function, and in this case it is increment without any option. And we also need to specify from which key, so the test. And as you can see, there is also an amount parameter that it's optional. And this is used only if you want to send also some tokens to the smart contract to do something. So you can imagine, for example, an AMM contract where user need to deposit some tokens to get an LP share. And in this case, you will use the -- amount flag to specify which tokens are you going to deploy. So in this case, we don't need it. Let's do it. And again, let's confirm the transaction. Again, let's query the transaction to see that it's successful. And as you can see, the raw log is here and we don't have any error. So the transaction has been executed successfully. And now we can repeat the query of the config of the smart contract. So that we can see that the counter will be increased by 1. So I did the exact same command, and now the value is 1. We can do it how many times we want, and every time the counter will be increased. We need, of course, to wait the transaction to be included in a block. So you can see that we went from 1 to 2. So that's it, and that's everything I wanted to show you in this small tutorial. Hope you like it. And of course, you can always come to our Discord, and in the developer lounge, you can ask any question you have and get in contact with us. We are always very happy to help you and check any idea that you might have. Thanks. Have a good one.